The last topic of the chapter 2 is sample spaces with equally likely outcomes. We have seen this idea before, but now we're formally trying to define this, and then that will lead to how we define probability of particular events in the future. Suppose the sample space has capital N number of equally likely outcomes, and we're using curly bracket to indicate each of the outcomes here. And then the sample space itself will be the union of all of the N equally likely outcomes. So by disjointness, meaning that there's no overlapping between any of the N outcomes here, then 1, which is the probability of sample space, and if you remember, this is from axiom 2 of our probability axioms. So by that, we know the probability of this sample space equals to 1, which will be the sum of all of the probability of each of the N events. And this is by axiom number 3. Okay, if you have disjoint events, then the sum of them, the union of them, probability of the union of them will be the sum of the probability. And lastly, because we know that the N events are equally likely, the N outcomes, I should say, sorry, N outcomes are equally likely. So you're going to use N times any particular event I. And by doing that, we're able to show that the probability of event I, any event I here, will be 1 over N. And that is because you have 1 equals to the probability of the sample space equals to N times P, any event I, and then we are able to show that. And this is related to, remember in the beginning, we talked about if you're rolling a 6-sided fair die, then the probability of getting any of the one of the 6 numbers will be 1 over 6. And that is because by axiom 2 and axiom 3, and also it's a fair 6-sided die, so you're going to have 6 equally likely outcomes, and that's why you're going to get 1 over 6. So from here, we can also come to the particular event E in the sample space as with equally likely outcomes. So if you want to find the probability of that event, essentially you're counting how many outcomes are in event E over the number of outcomes in the sample space. So we use this notation to denote cardinality. It's going to be the number of elements in set E. Let's look at a quick example. Probability of rolling an even number with a 6-sided die. We know that the event in this case is going to be 2 or 4 or 6. And then the sample space is 1 through 6. So if you're going to count how many outcomes are in each event, this one we have 3. And the sample space has 6. So by definition, from what we see earlier, the probability of event E will be the cardinality of E over the cardinality of the sample space, which will be 3 over 6, which is 1 over 2. So this exercise is for you. A couple has 2 kids. What is the probability that they are not both girls?